At first it seems improbable. How could it be that Tesla, who has never designed a chip before, would design the best chip in the world? But that is objectively what has occurred. Not best by a small margin, best by a huge margin. It's in the cars right now. All Teslas being produced right now have this computer.
Back in October 2016, Tesla announced that its vehicles will start shipping with cameras and sensors to support fully autonomous driving, through a software update and computer upgrade to come. According to Elon Musk, that day has arrived.
All cars being produced have all the hardware necessary, compute and otherwise, for full self-driving.
Tesla held an event for their investors called Autonomy Investor Day at their office in Palo Alto. The event showcased software upgrades to Tesla's self-driving technology, to be rolled out in a series of over-the-air updates. As of now, Tesla's autopilot feature enables self-driving on highways, on-ramps, and off-ramps, with periodic input from the driver. Tesla CEO Elon Musk also debuted a new computer called the Tesla FSD, or Full Self-Driving Computer. Previously known as the Autopilot Hardware 3.0 upgrade, the FSD is said to be currently in production, and will enable Tesla's software updates to work.
Here's what it looks like. I'd like to point out that this is actually a pretty small computer. It fits behind the glove box, between the glove box and the firewall in the car. It does not take up half your trunk. As I said earlier, there's 2 fully independent computers on the board.
The general principle here is that any part of this could fail and the car will keep driving. So you could have cameras fail, you could have power circuits fail, you could have one of the Tesla full self-driving computer chips fail, car keeps driving. The probability of this computer failing is substantially lower than somebody losing consciousness.
There in the top left, you can see the camera serial interface. We can ingest 2.5 billion pixels per second, which is more than enough to cover all the sensors that we know about.
In case you use, let's say, LiDAR, would it be able to process that?
LiDAR is a fool's errand, and anyone relying on LiDAR is doomed. Doomed. Expensive sensors that are unnecessary. It's like having a whole bunch of expensive appendices. Like one appendix is bad, well, now they want to put a whole bunch of them. That's ridiculous. You'll see.
All of autonomy, because you want level 4, level 5 systems that can handle all the possible situations in 99.99% of the cases. And chasing some of the last few nines is going to be very tricky and very difficult, and is going to require a very powerful visual system. So I'm showing you some images of what you might encounter in any one slice of that 9. So in the beginning, you just have very simple cars going forward. Then those cars start to look a little bit funny. Then maybe you have bikes on cars. Then maybe you have cars on cars. Then maybe you start to get into really rare events like cars turned over, or even cars airborne. We see a lot of things coming from the fleet. And we see them at some rate, at like a really good rate compared to all of our competitors. And so the rate of progress at which you can actually address these problems, iterate on the software, and really feed the neural networks with the right data, that rate of progress is really just proportional to how often you encounter these situations in the wild. And we encounter them significantly more frequently than anyone else, which is why we're going to do extremely well.
We have 8 cameras, but then we also have additionally 12 ultrasonic sensors, a radar, an inertial measurement unit, GPS, and then one thing we forget about is we also have the pedal and steering actions. So not only can we look at what's happening around the vehicle, we can look at how humans chose to interact with that environment. And so I'll talk through this clip right now. This basically is showing what's happening today in the car, and we're continuing to push this forward. So we start with a single neural network, we see the detections around it. We then build all that together with multiple neural networks and multiple detections. We bring in the other sensors and we convert that into what Elon calls a vector space, an understanding of the world around us. And this is something where, as we continue to get better and better at this, we're moving more and more of this logic into the neural networks themselves. And the obvious end game here is that the neural network looks across all the cars, brings in all the information together, and just ultimately outputs a source of truth for the world around us.
Does full self-driving capability make you want to purchase a Tesla more?